write it, some people will write it as 2000 or 2634.87. Well, why? Times 10 squared. That wasn't any help at all. Some people will write it as 26.3487 times 10 to the fourth. Why? That's wrong. And if you've been missing your scientific notation problems on your test, that's more than likely the reason. You can only have one, just exactly one, no less, no more. Just one number that isn't zero in front of the decimal point. So it's 2.63487 times 10 to the, okay, now that's a big number. So you're not going to have a negative exponent. Negative exponent is moving way down to itty bitty numbers. You just have to think a little bit. If that's a great big number, then these must be positive exponents. So you count over 1, 2, 3, 4, 5, and it would be 10 to the fifth. Now I'd like you to make sure you take a look at that on your tests where you've missed them, because that's the way it's been. And we're about to do some things that are a little more fun.
Yeah, this is what I do that. Yeah.
Now. Okay? All right, so now then, we are going to get started on this. Whatever this is. If I can find a lead in the pen, Alex, they want to see you in the attendance office.
Me?
Okay. If you had this number, we have 2,000. And we are going to multiply that by 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? You don't want to put 2,000 underneath there and just go 0, 0, 0, 0, 0, do you? Now, we've talked in the past about how to multiply with powers of 10. So if we could make this number a number with powers of 10, then it shouldn't be so bad, okay? So what would this number be in scientific notation, which is powers of 10? Georgia Lee?
Is that like 10 times like squared? Like 2.0.
2.0 times 10 to the what power? Third power, that's right. And this one would be what? What would it be, Caleb?
7.0 times 10 to the 9th power.
Right. 7.0 times 10 to the 9th. Okay, now, here's where it becomes easier. Yes? You don't need the 0.0 on there, no, but we'll keep it on there for right now. Okay? So what we're going to do is we're just going to multiply. What's 2 times 7? Everybody. 14. Okay, so this is going to be 14 times 10. We have 3 zeros here, right? 1, 2, 3. We have 9 zeros here. 3, 6, 9. So how many zeros do we have all day? 12. But that's not the answer. What's wrong with it? Justin, what's wrong with it?
It's still in scientific notation.
It's not in scientific notation. So in order to get it in scientific notation, what do we have to do? How many do you know we have to do?
1.4 times 10.
We have to make it 1.4 times 10 to the what? 13th power. This is how you multiply numbers that are in scientific notation. So this is what you would want right here. And you certainly don't want to write out all those zeros. They tell us on page 240 in your book that to multiply numbers in scientific notation, We multiply the numbers, we add the exponents of the decimal part, and then we write the product in scientific notation. We multiply the numbers, we add the exponent of the decimal point movers, and then we switch into scientific notation. Let's do another one. Let's do three times 10 to the 5th power, and you're going to multiply that by 3 times 10 to the negative 8th power. Okay, so now the first thing you do is multiply the numbers. What are you going to get? You all should know what 3 times 3 is.
Oh, 9.
9, okay? So we're going to have 9 times 10. Now then, to determine what it's going to be, we have to add the exponents. 5 and negative 8 is how much? Negative 3. And in this case, we're already there because it's a negative exponent. Let's do this one. We have 7 times 10 to the negative 5 times 8 times 10 to the 3rd. You multiply the numbers times 10. You add the decimal point movers